Hi students, how are you? I think it's fine. And previous class we discussed about the basic concept of the noise pollution. That means what is the sound intensity, what is the sound pressure, etc. etc. But today we'll discuss about the classification of the sound and the expression of the decibel. Then there is a term that noise threshold limit. That is also we'll discuss today. And also we will discuss L10, LEPN and L equivalent index. So myself Tanmoy Dotto, Assistant Professor, Department of Chemistry, JS College of Engineering, welcome you all in my second class of noise pollution. So if we classify the noise or the sound, actually there are mainly two types of sounds are there. All of you know very well there are two types of sound. The one is the musical sound. First one is the musical sound and another is the noise. Okay, so one is the musical, another is the noise. So how we can differentiate between which is the musical sound and which is the noise? The sound of which produces a pleasing effect on the ears of the listener is called the musical sound. A musical sound consists of a series of harmonic waves following each other at a regular interval of time. This is very much important factor that there should be a rhythm. There should be the waves should be at a regular interval of time. Okay, so this is the important fact and which produce the pleasing effect, actually a regular interval of time. Okay, so this is mainly responsible for to create some kinds of pleasing effect in our ear. But in case of a noise, there will be not any kind of a regular interval of time. There should be irregular interval of time. Okay, here irregular interval of time. There should not be any regular interval of time. That's why noise does not create any kind of pleasing effect in our art. Examples, there's some examples of the musical sounds of which is created different kinds of instrument. Like if you think about the piano, okay, all of us, I think there is a very interesting or very sweet sound which is coming from the piano, isn't it? So the sound which is coming from the piano, this is called the musical sound. A violin, guitar, that all are the sounds which are coming from the musical instrument, and that are the musical sound. On the other hand, if your house is nearby any industry, then different kinds of noise always come throughout the day. There was not any rhythm and it will not create any pleasing effect. So these kinds of sounds are called actually noise. So in case of noise, the waves are actually irregular interval of time or sudden change in their amplitude. It creates the noise. Okay, so this is the difference between musical sound and the noise. You have to keep in mind because this is very much important for your exam purpose. What are the differences between musical sound and the noise? Now come to the next part. Okay, so in the next portion we discussed about in the previous class what is the dB, but in today's class we'll see what is the we discussed also that what is the expression of the dB. So in this class we'll discuss about that the mathematical expression decibel, mathematical expression dB equal to it will be 10 log of I by I0. What is the I and what is the I0? I is the measured intensity. Okay, so what intensity of the sound is, this is called the I. And I0, what is the I0? I0 is the reference intensity. Okay, so you have to keep in mind in the equation of dB, I is the measured intensity and I0 is the reference intensity. Now you know that if we consider with respect to pressure, then we know that I proportional to P, that means pressure. So intensity proportional to pressure. So in the same way, I0 we can write down I0, actually it is P square, I0 proportional to P0 square, isn't it? So if intensity proportional to P square and I0 reference intensity proportional to P0 square, then what we can write down? We can write down the equation in the form of like dB equals to so it will be 10 into 2, that means 20. So it will be 20 log of P divided by P0, isn't it? So this will be the final equation for the final equation of the decibel with respect to the pressure. So this equation also important, or you have to keep in mind for your numerical problem purposes. Today we'll discuss about some numerical problems also, then it will be more clear for you that how you can use this equation. Okay, so for example, this is the question. You have to calculate what will be the intensity of the 100 decibel sound where I0, this is given in the question that I0 is the 10 to the power minus 12 watt per meter square. This is given in the question paper. So how you can calculate? You know that the you know what is the equation. First write down the equation. So it will be 10 log I by I0, 10 log I by I0. Okay, sound level or dB equals to, so here dB is the 100, so we can write down that 100 equals to 10 log I by I0. So you have to find out the value of I, but I0 value is given, so it will be 10 to the power minus 12. So to solve this equation, after solving this equation, you will get I is equal to 10 to the power minus 2 watt per meter square. So this is the answer for you. So in this way you have to solve the problem. I will show you another problem also after discussion of the topic. Okay, it's no problem. So this type of question you can expect in your exam time, so you have to solve in this manner. Okay, now we will discuss about the L10 and L equivalent. What is the L10? So if we consider the L10, then it is the arithmetic average. It is the arithmetic average hourly values of the noise level. Now if we consider the L10 index, which is considered over 18 hours, or which is taken for 18 hours, then we can define that it is the arithmetic average hourly values of noise level exceeded for the 10% time over 18 hours between 6 to 24 hours on any normal weekdays. And this scale is used for measure the road noise in UK. This is the standard value actually, which is used in the UK to measure the road noise. So you have to keep in mind from here that what is the average. This is the first of all L10 index is used for 18 hours. Okay, so this is the important factors, and it is taken in between 6 to 24 hours. Okay, so in any normal days, and normally it is used for the to measure the road noise. Okay, these factors you have to keep in mind. Now come to the next type of index, that is the equivalent noise level. It is the weight average sound level over time measurement and is represented by L equivalent and given in dB unit. The time measurement is specific and measured for a short duration, usually when noise level is most prominent. So L equivalent, this is measured in the for the short duration, if the measurement is done for different time duration, the value will differ. So obviously if the time, if it is taken for different time duration, because in like the previous case, look here in L10 index, look here, there it is taken for in between 6 to 24 hours, but here it is measured for the short duration. So that's why it is taken. If it is taken for the short duration, then obviously it may differ from time to time. If the measurement is done for a specific period of the time, they started at the same time but in different place, it may not be the same. This is the same case. So L equivalent, it is used for a measurement of the noise level in the industrial traffic as well as the residential area. So this is also important. From here you have to keep in mind. So where it is used, you have to keep in mind, like in case of L equivalent, it is used for the industrial traffic as well as the residential areas, but in case of L10 index, it is used for the road noise, okay, to measure the road noise. So now come to the point that what is the anthropogenic noise. Okay, so in case of anthropogenic noise, the different types of anthropogenic noise. First one is the transport noise, okay, second one is the occupational noise, third one is the neighborhood noise. The transport noise is the subdivided, again the transport noise is subdivided into the three categories. One is the road traffic noise, second is the rail traffic noise, and obviously aircraft noise. Okay, so it is very much clear from here that there are three types of anthropogenic noise. So first one is this may be the question also, you have to keep in mind that how many types of anthropogenic noise are there. So first of all, you have to keep in mind that in case of anthropogenic noise, there are mainly or majorly there are three types. First one is the transport, second one is the occupational, and third one is the neighborhood. And again the transport noise is classified in the road traffic. There are three types of transport system, rail traffic and the aircraft noise. Okay, now come to the most important part, that is the noise threshold limit, or how we can define the noise threshold limit. The noise threshold limit values, actually what is the meaning of the noise threshold limit? There is a maximum permissible limit of the noise, that is called actually noise threshold limit. That means for a human being, how much noise it can be bearable for a particular human being for a particular period of time, that is called actually noise threshold limit. So noise threshold limit values, as per the American national standard specification, there are some values which you have to keep in mind. Okay, so the daily noise exposure is composed of two or more periods of the noise exposure of different levels. Their combined effects need to be considered rather than the individual effects of each. So when the sum of the following factors, like here, this is very much important. Okay, so keep in mind that C1 by T1 plus C2 by T2, that dot Cn to Cn by Tn. That means C, what is the C and what is the T? Cn indicates the total duration of the exposure permitted at the that level, and Tn indicates the total duration of exposure permitted at that level. Okay, so I'll give you some examples also, then you will understand that what is the permissible limit of the noise threshold. So look here, that if there is any work area, what is here, if any work area, the noise level are read as the 100 dBA for 3 hours in a day, 85 dBA for 2 hours in a day, and 80 dBA for remaining 3 hours in a day. And also the permissible exposure also mentioned in the question, that it is the 100 dBA is the permissible limit is the 1 hour, 85 dBA 8 hours, and 80 dBA 16 hours. That means try to understand the question at first, what is mentioned here or what you have to do actually. Here there are two things you have to keep in mind, one or two things you have to understand properly. So one is the measure time, okay, and another is the reference time or the permissible limit. Okay, so 100 dBA, if you think about the 100 dBA, there it is, the measure is the 3 hours. Okay, but its permissible exposure is the 1 hour. Okay, so in case of same way, if you think about the 85, that is the 2 hour, but it's permissible 8 hour. Okay, and 80 dB, it's 3 hour it's practically we observe measured 3 hours, but it permissible 6 hours. So that means, what is the meaning of these factors? That permissible means up to that hours we can or any person can hear the sound up to that level. Okay, so according to our equation, that what is the equation? The equation is that it is the C1 by T1 plus C2 by T2 plus Cn by Tn up to Cn by Tn. So first one, what is the C and what is the T? Okay, you have to understand at first what is the C and what is the T. So the C is the, first of all, C is the, it is the measured. That means if you think about measured, so for the case of 100, so measured is the 3, so we can write down it is a 3, and your permissible will be it's 1, so we can write down 1. Okay, so plus next will be it's for 85 dB, it's 2 hours, so it will be 2 divided by its permissible is the 8 hours, so 2 by 8. Okay, plus the next one is the 80 dB, it's measured 3 hours and it's permissible 16. So C means it is the measured value, and the T means it is the your permissible limit. So you have to calculate that what is the value for this. Okay, 3 by 1 plus. Okay, so now if you face such kind of question that you have to add 80 dB sound and the 120 dB sound. Okay, so how is it possible to add the 80 dB and the 120 dB sound? So first of all, I will take I1 is the it is the measured intensity, and I0 is the standard intensity. Okay, so now for if we use the equation which we discussed in the for the decibel, then we can write down that for the case of 80, we can write down 80 equals to 10 log of I by I0. We can write down. So from this equation we can for the first case we'll take the I1. Okay, so then we can write down from this equation, we can write down I1 equals to I0 into 10 to the power 18. We can write down. We can also write down for the second case for 120 dB. Suppose we are taking that it is the measured intensity is the I2. So first case it is the I1, and second case we are taking that I2. So I1 for 80 dB and I2 for 120 dB we are taking. So in the second case we can write down 120, that equals to 10 log I2 divided by I0. So from this equation we can write down I2, that equals to I0 into 10 to the power 12, isn't it? So in first case it will be 10 to the power 12, or okay, so first case it will be 10 to the power 8, and in second case it will be 10 to the power 12. Okay, so now if we have to add the two sound, that means 80 dB and 120 dB, then obviously we can write down that I1 plus I2, that equals to, we can write down that what will be the equation? It will be the I0 is the common factor, So I0 into, we can write down 10 to the power 8 plus 10 to the power 12. So we can write down I1 plus I2 equals to I0. That means we are adding what we are adding, we are adding actually look here, that two equation. That means it is the I1 and it is the I2. Okay, so then we have to calculate after addition what will be the sound intensity. So we are taking for this purpose that sound intensity will be for example, sound intensity will be, for example, we are taking, it is the L1. Okay, so if we are taking that sound intensity will be L1, then L1 equals to, we can write down that L1 equals to I1 plus I2 divided by I0. Okay, so I1 plus I2 divided by I0. So we can write down from this equation, we can write down, we know that I0 cancel out, I0 and I0, this will be cancel out, and the remaining part will be this one, 10 to the power 18 plus 10 to the power 12. Okay, so 10 to the power 18, and there will be okay, so here will be L1 equals to here will be 10 log. Okay, I will show you again. Okay, I will show you again. There should be 10 log value which I missed here actually, so I will show you again here. Okay, so from the starting point I will show you that what will be the equation for the case. Okay, so now look here. So L1 equals to it will be 10 log I1 plus I2 means it will be I0. So I will show you that L1 equals to L1 equals to in the upper portion it will be 10 log then I1 plus I2, that means I0 into that value, that means 10 to the power 18 plus 10 to the power 12 divided by I0. So I0 it will be cancel out, so I0 cancel out, so remaining part will be L1 equals to here you can write down L1 equals to 10 log of into 10 to the power 8 plus 10 to the power 12. Okay, so what will be the final value? This will be the answer. So in this way you can find out the answer of the question. There may be such kind of question where you have to add this type of two sounds, or the question may arise in this way also, that that if two machines produces 50 decibel sounds simultaneously. Okay, if it is mentioned in the question that, for example, if there are two machines which are producing 50 decibel sound simultaneously, what will be the total sound level? So in the same way you have to do. Here we are taking the two sounds as 80 decibel and 120 decibel. There in the both cases it will be 50 decibel, so no problem regarding this fact. So you can use that the same formula and you can find out what will be the final level of the sound. Okay, so this is all about your syllabus of the noise pollution. And what question you can expect from the noise pollution, I can tell you that there may be the question like what is the sound pressure, what is the sound intensity, what is the sound frequency, what are the differences between musical sound and the noise, what is the decibel, what is the equation of the decibel, how we can express the equation of a decibel with respect to pressure, what is the L10 index, what is the equivalent sound level or equivalent sound index, what is the sound threshold limit. There may be some kinds of numerical problems also from the threshold limit, and such kind of problem from the decibel also you can expect. Okay, so thanks to all of you for attending my class. Meet with you in the next class with a different topic. Thank you. Thanks a lot.